Hello, my name is Kenneth, and today me and Joey will be talking about the pancreas. So the pancreas has two main functions, and they are exocrine and endocrine. Its exocrine function involves releasing digestive enzymes to aid in the digestion of food. Its endocrine function involves regulating blood sugar levels. And two main hormones produced by the endocrine pancreas are the first one is insulin, which is produced and released by beta cells in the pancreatic islets or the islets of Langerhans when blood sugar levels rise. Its primary function is to lower blood sugar levels by facilitating the uptake of glucose into cells, and it promotes the storage of excess glucose and helps maintain blood sugar as well. The second hormone that is produced by the pancreas is glucagon. It is produced and released by alpha cells in the pancreatic islet as well when blood sugar levels drop. The primary function is to raise blood sugar levels by stimulating the liver to break down glycogen into glucose and release it into the bloodstream. And it also promotes the conversion of amino acids and other substrates into glucose in a process known as gluconeogenesis. And so the pancreas anatomy. So here is a picture of the pancreas, and as you can see, it has many parts. You can see it has a tail, a body, and a head. And you can also see that it has many ducts, such as the pancreatic duct, the common bile duct, the accessory pancreatic duct, and it is located next to the duodenum and also next to the gallbladder. Um, and it also has lobules as well as duodenal papilla. So why is the pancreas essential to the body? Well, first, it helps in digestion by producing enzymes such as amylase and lipase, which break down carbohydrates and fats, respectively. It also produces sodium bicarbonate, which helps to neutralize stomach acids in food. Additionally, it produces insulin, which helps regulate blood sugar levels when it is too high, and it produces glucagon, which also helps regulate blood sugar levels when it is too low. So, some disorders that are related to the pancreas are diabetes mellitus and pancreatitis. So, diabetes mellitus is a group of metabolic disorders characterized by high blood sugar levels over a prolonged period of time. The two types are type 1 and type 2 diabetes. Pancreatitis is the inflammation of the pancreas. So this can either be acute or chronic, and it is usually caused by things such as excessive alcohol consumption or gallstones. Um, and this also, like I said, has two types, acute and chronic. So type 1 diabetes mellitus, it is an autoimmune disease. The pancreas does not produce insulin, and the immune system basically attacks the islet cells that produce the insulin. Type 2 diabetes mellitus involves the pancreas not producing enough insulin. So the body becomes resistant to insulin, and so it is unable to use its own insulin, and this is why insulin injections are required with this type of diabetes. And so some symptoms of type 1 and type 2 diabetes are extreme thirst, fatigue, blurred vision, irritability, increased urination, headaches, poor wound healing, and nerve damage. This is known as diabetic neuropathy. This basically occurs because when there is an increased level of sugar in the blood, it can cause damage to the blood vessels, and this can eventually lead to nerve damage in the long run. Acute pancreatitis is inflammation of the pancreas, and it usually it's an emergency when it's acute because the pancreas becomes inflamed, so it requires rapid treatment, and And the reason for this is because when it is inflamed, enzymes can't leave the pancreas. It results in burning and irritation. Some common causes of this are alcohol consumption and gallstones within the bowel tube. Other factors include mumps, trauma to the pancreas, and as well as pancreatic cancer. Chronic pancreatitis is different in that it is a recurring events of inflammation, so it's more than once, and alcohol consumption increases the risk of this type of pancreatitis, and the constant inflammation damages the pancreas, resulting in reduced function of it. Some symptoms are upset digestion and fatty, foul-smelling stool. So for diabetes mellitus, there are some treatments, even though there is no known cure for it. These treatments include lifestyle modifications such as changes in diet, increased physical activity, and weight management, as well as insulin injections, and blood sugar monitoring with the use of the glucometers is a good way to see how an individual is doing in regards to their blood sugar and making sure that it's not too high or too low. And pancreatitis, so some treatments for this are fasting, enzyme replacement, alcohol and smoking cessation, and in rare cases surgery. Um, Insulin injections are used as well, and this can be because of in severe cases of pancreatitis, um, it can damage the pancreas and therefore it can't produce the insulin that is needed. So this is why insulin injections are sometimes used. And yeah.
Okay. Hi, my name's Joey. So basically, I'm going to be talking about why the body would not be able to function without the pancreas and why exactly it is so important. Um, so we thought the best way to go about this would be to pretty much kind of interrogate the other organs that it either directly or indirectly correlates with, whether they be endocrine, fellow endocrine organs, or just other organs within other systems in the body, like the circulatory system, digestive system, etc. I mean, they're all systems, so they are all going to work together. And yeah, so we've kind of compiled together a little pitch, basically questioning these other organs and what exactly they would possibly be able to do without the function and the aid of the pancreas and the things that it does for the body and for the other organs. So yeah, so the body could not function without the pancreas, and we're going to explain why to all of its fellow organs. So the first, oh, actually, before I do that, so these are some of the organs that the pancreas is either going to directly or indirectly work with, correlate with. Like I said, either some part of the endocrine system, part of the circulatory system, digestive system, all systems working together. All these organs, because they're systems, they need to work together in order to function properly. And the pancreas is obviously, in consideration with that. Without the pancreas, none of these organs are going to be able to function properly. So yeah, the pancreas is a vital organ within both the endocrine and exocrine functions, with both endocrine and exocrine functions, plays a crucial role in maintaining glucose homeostasis and aiding in digestion. These interactions highlight the pancreas' central role in regulating metabolism, digestion, and overall energy balance in the body. Dysfunction in these interactions can lead to metabolic disorders such as diabetes and impact the health of multiple organ systems. So the first organ that's going to be kind of on our chopping block is going to be the liver. So just to question the liver, who would aid you in the regulation of insulin and glucagon in the body? So how would the liver know to break down glycogen into glucose to release it into the bloodstream? And how would you know to stimulate the process of gluconeogenesis during low glucose conditions? And how would the body possibly be able to maintain glucose homeostasis without it? So the pancreas and liver interact closely to regulate digestion and maintain glucose homeostasis. Additionally, the pancreas regulates blood glucose levels through the actions of insulin and glucagon, influencing the liver's glucose production and storage. This coordination between the pancreas and liver is vital for overall metabolic balance in the body. So, pretty important stuff. I don't know what the liver's going to do without the pancreas. So, to the small intestine is the next guy we're going to be talking about. Who would secrete your digestive enzymes to aid you in the breakdown of nutrients? So, who would provide the small intestine with pancreatic amylase for the breakdown of carbohydrates into smaller sugar molecules like maltose and glucose? Or pancreatic lipase for the digestion of fats to break down triglycerides into fatty acids and monoglycerides? Or proteolytic enzymes to break down proteins into smaller peptides and amino acids? So the pancreas supports the digestive process in the small intestine by providing enzymes that break down carbohydrates, fats, and proteins into absorbable nutrients. This is going to be a exocrine function of the pancreas, so not necessarily anything to do with hormones, but nonetheless still very important. This collaboration between the pancreas and the small intestine is crucial for nutrient absorption and overall digestion within the gastrointestinal system. So to the stomach, how is the stomach supposed to properly perform gastric emptying without the hormones provided by the pancreas? So the release of cholecystokinin or CCK and gastric inhibitory peptide GIP allows for more controlled digestion and absorption in the small intestine. So basically, gastric emptying is influenced by various factors, including the composition of chyme, the presence of nutrients, and hormonal signals. For example, the release of certain hormones, such as these two, in response to the presence of food in the small intestine can slow down gastric emptying. This slowing down will allow for more controlled digestion and absorption in the small intestine. Okay. So to the adipose tissue. So who's going to regulate the insulin secretion in order to promote and inhibit other functions? So insulin promotes lipogenesis, which is the process of converting excess glucose into triglycerides within adipose tissue. Insulin inhibits lipolysis, the breakdown of stored fatty acids and glycerol. And adiponectin is also involved in insulin sensitivity and glucose metabolism. So basically, the pancreas, through insulin secretion, plays a crucial role in regulating glucose uptake, lipid storage, and energy balance in adipose tissue. Dysregulation of this interaction, as seen in conditions such as insulin resistance, can contribute to metabolic disorders such as type 2 diabetes and obesity, which obviously we do not want in the body. The body is not happy with those kind of disorders. We don't want those. Alrighty, so to the hypothalamus and pituitary glands. So without the pancreas, what would happen to the numerous processes that involve your shared interactions? So without the pancreas, there would be no neural signaling. So the hypothalamus communicates with the pancreas through neural signals. Sympathetic and parasympathetic branches play a role in modulating insulin and glucagon secretion. Sympathetic activation inhibits insulin release, while parasympathetic activation stimulates it. Without the pancreas, there would be no hypothalamus pituitary adrenal HPA axis. This axis directly interacts with the pancreas. Stress and other factors activate the HPA axis, leading to the release of cortisol from the adrenal glands. Cortisol influences insulin sensitivity and glucose metabolism. And then without the pancreas, there would be no feedback loops, which are super important. There are feedback loops between the pancreas and the hypothalamus pituitary axis. Insulin influences the release of growth hormone, and growth hormone influences insulin sensitivity. So the pancreas communicates with the hypothalamus and pituitary glands through neural and hormonal pathways, contributing to the regulation of glucose homeostasis and overall metabolic balance in the body. This intricate system helps ensure that blood glucose levels are maintained within a narrow range to support energy needs within the body's cells, which is super important because without energy in the body's cells, those cells cannot perform. And without those cells performing, the body cannot live. The body needs its cells to be functioning properly in order to do anything pretty much. So pretty important stuff, huh? And lastly, last guy on the chopping block here is going to be the body's blood vessels and circulatory system. So who's going to regulate your blood glucose levels without the pancreas? Kind of a running theme here, but nonetheless, very important. So what will you do without the pancreas's islets of Langerhans secreting insulin and glucagon? Without this negative feedback loop, how will the bloodstream maintain proper blood glucose levels? And maintaining this homeostasis is critical for cardiovascular health within the body. So the pancreas interacts with the circulatory system by releasing hormones, alpha and beta cells, into the bloodstream to regulate blood glucose levels. Additionally, the blood vessels supply the pancreas with the oxygen and nutrients it needs to function properly. So clearly, these two work together. One needs the other, and the other needs the other to function properly. So if the pancreas isn't there, what's the blood vessels in the circulatory system going to possibly do? Which I don't know. I really don't know. So basically, can you now see why the pancreas is so important? Clearly, it has a lot. It has numerous functions, some pretty consistent with others. There definitely seems to be a running theme with blood glucose levels, insulin, glucose homeostasis. But of course, this is all extremely important for maintaining normal levels and normal function within the body. And yeah, without the pancreas, none of these systems are going to be able to work properly. And if one system doesn't work, the rest of the systems are going to fail. And then the body's going to fail. And we don't want that. So that's why we love you, pancreas, from all your little friends and from us. Great guy or girl. We love you. Okay. And these are our references. All right. Thank you so much. Appreciate you. And yeah. Okay. Bye.